Welcome back to Electrons Dance. Today let's look at another consumer device that failed recently. My old wall beard trimmer. Not that I have much to trim anymore. The symptom I'm seeing is severe loss of battery capacity. If I leave the device on charge overnight, I can use it for several minutes, usually enough to do a quick trim before going out. But if I unplug it and leave it on the counter for a couple of hours, the battery doesn't have enough juice to cut anything. Most likely the charger is fine, but the battery is going bad. The fix should be easy peasy, right? When I first decided to replace the battery pack, I didn't think this was worth making a video about, especially since it seems there are already several online about this type of repair to similar products. Then I opened up the trimmer to check the battery type in preparation for ordering a new battery online. It turns out that the battery pack in this unit is 2 AA NiCad cells in series, which I couldn't get from DigiKey, but which were available via Amazon in a 12-pack, which would mean keeping 10 uncommon batteries lying around. The rated capacity was also an issue. While I have it apart, why not upgrade to nickel metal hydride cells with about 3 times the capacity? But that would mean using a different charger, right? I was assuming the external charger had automatic cutoff, tailored to the battery chemistry, but that doesn't seem to be the case. In fact, the external charger is probably just a basic power supply with a fixed voltage output, with charging controlled inside the trimmer. For one thing, the LED charge indicator stays lit as long as the device is plugged in. I also confirmed with the bench test that the charger just puts out a steady voltage regardless of the current draw and regardless of the voltage of the simulated battery pack. Unfortunately, that means I can't just install a nickel metal hydride battery pack and buy a wall wart meant for charging the same. So let's look at the charging circuit inside the trimmer. Wow. It's just a current limiting resistor and parallel LED indicator. That's a great way to reduce battery life. But on the plus side, it is cheap. Here's a schematic showing the wiring inside the trimmer. There's a small circuit board carrying the barrel connector where the charger plugs in. There's another circuit board with this charging circuit and point-to-point wiring connecting those to the trimmer motor and the battery pack. These two switches are actually formed by a pattern on the circuit board together with an actuator that slides across the board with metal spring contacts. They're mutually exclusive. When in the operate position, switch 1A is closed, connecting the trimmer motor to the battery pack. And in the charge position, that one's open, and switch 1B is closed, connecting the charger to the diode, current limiting resistor, and so on to charge the battery. Pretty primitive. This is where the impractical bit comes in. I have an overpowering urge to upgrade the charging circuit when I do the battery swap. And that means building a new circuit board with a nice charge controller IC, way beyond what is justified for an inexpensive hair trimmer. Oh well, I'm in the grip of an irresistible impulse, so I've drawn this schematic for the new charging board. Most of the components here are the same. I'll use the same connector board, and of course I'm not touching the trimmer motor. I will be changing the battery pack to nickel metal hydride cells, And the charging board I will replace with this one, which is much more involved. I'll match the circuit board pattern to use the same slider. I'll use this benchmark charging IC, which is tailored to the nickel metal hydride cells. The charging is automatic. It will cut off automatically when the battery is fully charged, and also has a timer. So even if it's not fully charged, it'll cut off after a certain number of hours, selected by a resistor value here. Charging rate and number of cells are selected by some other programming resistors. A lot more involved than the original charging circuit, but it should maximize the life of the battery pack. Yeah, the 3D views are always fun to play with in KiCad. Even though I haven't bothered to make a 3D model for my footprint for some of the components. Okay, I'm ordering the minimum 3 boards from Osh Park. Looks like that's going to be pretty cheap for this small board. I'll order the parts I need from DigiKey. Okay, so I finally have the PCB and components for the new charging circuit. Normally I would just solder everything by hand if I'm only building one board. But with this fine pitch IC, my technique might not be up to snuff. So I had a stencil made, and we'll try to paste and reflow everything. If that doesn't work, I'll touch up by hand. So here's my usual drill. Line up the stencil. Squeegee on some low temperature solder paste. Inspect and touch up the paste on this fine pitch IC. Place surface mount components. Reflow solder on the hot plate. Touch up as needed. Solder any through-hole parts, wires, etc. And test. Wow, the charger IC seems to be working right off the bat. The status LED blinks like mad with no battery connected, and on steady while charging the new battery pack. I'm a lucky dog. Okay, let's install all the electrical stuff in the trimmer body. I overlooked some notches needed in the PCB, so I added those crudely with diagonal cutters and an X-Acto knife. Oops, my blocking diode is in a bad spot, interfering with a plastic tab, so I trimmed the plastic. The battery space is too tight for the hand soldered battery terminals, so I removed some plastic tabs that were in the way. Now it all fits. Time to reassemble the trimmer and try it out. The slide switch works, the motor runs, and with the switch-in charge position and the wall wart attached, it seems to be charging with the indicator lit steady. After a while, it reaches end of charge, hits the voltage limit, the batteries get a little warm, and finally it stops charging and turns off the status LED. Back in service at last. So what's the bottom line here? When I go to the time, trouble, and expense of repairing some inexpensive gadget like this, it's usually not for practical reasons, but just for the satisfaction it gives me. I hope some of you out there will enjoy a totally impractical repair job now and then. Good day.